Hello, everybody. So today's topic: switching fundamentals. So today's agenda is to look into the difference between the hubs and the switches. What is a collision domain, and what is a broadcast domain? So before that, I will be introducing the IP concept. So I'm going to introduce a one single IP network, which is widely used, which is nothing but 192.168.1.0 network. Because if you take a network, any network devices, so if you take any network devices, everything has to be assigned an IP to it. So it plays a major role. So without wait, let's get started. So first of all, the IP address which I'm going to introduce is IP addressing. I'll be introducing 192.168.1.0 network slash 24, which is a subnet basically. So how does it look? So 192.168.1.0 to 255.255.255.0. So this is how it looks like. The number of usable IP addresses, and so let's see what you can use it and what we cannot use it. So IP address of 192.168.1.0, you cannot use it because it's the network address itself. Network 192.168.1.255, you cannot use it because this is the broadcast IP address. So these both IP addresses we cannot use it. So the number of IP address within this 192.168.1.0 to 255, you can see it. The total is 0 to 255 is actually 256. If you count it, my bad, 256. And then you have to reduce 2 IP from that, so which is network address and broadcast. So we will be ending up with 255, 254. And that's it. So we will be assigning the IP addresses to the several networking devices as we go. I will leave this right here so that you will have some understanding about it. The first topic is about the difference between the hubs and the switches. Let me go ahead and grab a hub, and I'll connect 4 PCs. 1, 2, 3, 4. Then I'll connect them with the cables, which automatically does it. I will grab a switch as well, and I'll connect 4 PCs to it. 2, 3. I'll connect with the cables as well. This one is hub, and this one is our switch, and we'll see the difference between them. All right, first thing first, we will go ahead and assign the IP address to each of the PCs. I will assign 192.168.1.1 address, because I cannot use 0 since it is network address as I told you before, and the subnet will automatically takes it. Let me copy this address, and I will go ahead and assign to the rest of the PCs. Big interface 0, 2, this one, 3, this one. I'll assign 4. So as we are going to see the difference between the hubs and the switches at the same time, I will go ahead and assign the IP address to these PCs as well. So the first one will be 1.1. We are completely using it in a different way, so the IP address will not clash between them. My bad. So this should be 2. This one will give 3. For this one will give 4. Alright, so as we assign the IP addresses, we'll look the first one. So what is the difference between them? So the first point is both of them are networking devices, so which connects multiple end hosts. So hubs will operate at the layer 1, switch will operate at the layer 2. So the main difference is how the frames are being processed and delivered. So if you see in the hubs, if you try to ping from PC0 to PC3, it will not only pings the specific PC, it will also send the frames to all the PCs which is being connected in the hubs. We will go ahead and see in the simulation mode. Let me grab a ping. So I'm trying to ping from this PC 0 to PC3. Let's see how it behaves. As you can see, the frame is going to the hub and it is going to all the 3 PCs. I mean the rest of the 2 PCs. Right? It's a normal behavior as it is flooding and learning. But if you see it again, if you try to ping the PC3 from PC0 again, it will again does the same thing. So meaning that it is not efficiently working. So it is actually flooding the frames to each and every specific ports. So basically it is broadcasting. So in the hub, the frames destined to the specific ports will be broadcasted to all the ports. So that's the takeaway from that one. And if you can see in the switch, we will go ahead and delete this and grab one. If you can see in the switch is different, right? So the switch is an intelligent device which has a capability of learning the MAC addresses and forward the frames to the destination. So say for example, I'm pinging from PC4 to PC7. So initially the frame will be forwarded to all the, I cannot say forward actually, it floods to all the, all the 2 remaining PCs right here. And for the second time, if you try to ping the same device again, it will only forwards the frame to the specific PC7. So meaning that again, it is an intelligent device. It's learning the MAC addresses and forwarding the frame to the specific PC that has learned. So if we see another difference is that the ports of the hub will create a single collision domain and leading to operate in half duplex mode. So what do I mean by that? So I will try to ping the device PC0. Let me just delete this first, the scenarios. We grab a packet again. I'm trying to ping from PC0 to PC3, and also again I'm trying to ping from the PC3 to PC0. So we'll see what happens. As you can see, both of them sending the frames to the hub. It is colliding each other, as you can see it. So it's burning right here. So it is colliding, and the packet which is being delivered will also be corrupted. So this is what I mean. So it leads to collide with each other and will operates in only in the half duplex mode. But if you see in the switch, if you try to delete the scenarios again, take a packet, try to ping from PC4 to PC7, and ping from PC7 to PC4. Let's see how it behaves. So as you can see, both of them are sending to the switch. Switch is sending back and it's accepting it. So meaning that it is not colliding. It is operating in full duplex mode. A switch, each and every port will act as a collision domain. So it's between the switch and the PC. So a collision will never happen in the switch as it is learning the MAC addresses and forwarding it. Understanding them is the main point. So a collision domain is nothing but, as I explained it before, it's a shared communication medium. So when 2 or more devices trying to speak to each other, the communication becomes garbled due to the collision. To prevent the data collision, Ethernet includes the carrier sense multiple access collision detection. This means a device could perform only one action at a time. So let me just write it down so that you will have an idea. So shared communication medium. All right. What is a broadcast domain? A broadcast domain is nothing but when a device resides on the same layer 2 segment are considered to be in the same broadcast domain. That's it. So that's the definition of it. A broadcast is nothing but a broadcast traffic intended for every host on the local area network, and it will be forwarded out on every switchboard interfaces. So that's the definition of a broadcast domain itself. So as you can see, an excessive broadcast traffic is good for nothing. So it is good. It is undesirable. It will reduce the efficiency of a network. All right. So we'll see in another example of the how we can actually just reduce the broadcast domain. So a good example will be a router. A router, which is a layer 3 device, will not forward any of the broadcast traffic. So let's see an example. I'll take a router. I'll take two switches, connect it here and here, and the PCs here. And let me just connect them with the cables required. So we have connected everything, and let's go ahead and assign the IP addresses. First, I'll assign the IP address to the PC. I will give 192.168.1.1 IP. I will add one more PC as well for better understanding. I will assign this PC IP address of 192.168.1.2. The IP address for the router for this interface conf. So let me explain it clearly. I'm gonna give an IP address. This network has 192.168.1.0/24 network. This one on the other side will have 192.168.1. 2.0 network. And now it's clear, and we will assign the IP address appropriately. All right, so I'm into the config mode. Interface gigabit Ethernet 000. IP address, I'm giving 192.168.1.100 for this specific router, and no shit. And then for the other interface as well, I'll give interface gig 001. IP address 192.168.1.2.100. Let me give 2.100 for this one. No shirt, and save the config. And for this PC, we will assign 192.168.2.1 address, and it's time to assign the gateway IP for each and every specific host that we have created. For the gateway, I'm giving 192.168 1.100. We will look into the IP addressing, routing, the later chapters, but for this example, I'm just going ahead and doing this one. I will give 192.168 1.100. It's a gateway IP, and for this PC, we will give 192.168 2.100 as the gateway IP. Right. Let's put it in the simulation mode and we'll test it right here. I'll take a packet and I'll try to ping PC8 from PC8 to PC10. You can see that packet is actually going to the switch and to the router and also to the PC, and you can see that the router is rejecting that packet as a final result that the network broadcast do not cross the layer 3 boundaries, that is from one subnet to the another subnet. And let's complete it. As you can see, the packet just went from the PC10 back to PC8 as it is pinging from the same broadcast domain. That's it for this video. We will look into more details from in the upcoming videos. Thank you so much for watching. Stay tuned for the next videos again. Bye now from Rogan.